Well, thank you guys for coming. Thank you guys for having me. It was Mike's idea to do a German Christmas market with a German type of talk, and that was the best German he could get. It's Martin Bach's birthday today. That was his reason for not coming today. At least that's what he told me last week. So I'm doing 2 talks today, and the first one is about baselines or SQL plan management, and I hope that one will be useful. And the second one will be, I think there will be a lunch or a dinner or food thing between. The second one is called 12 Senior Features, which is actually quite an interesting one because you can tell there are some features that I talk about that I'm very familiar with, and some where I'm just faking it. Just feel free to ask questions. I mean, this is a small, intimate group. If you have any questions or anything, if you know more about the stuff than I do, which is highly likely, then just shout at me and let me just learn something here, right? So this being said, that's the title of the presentation. Very exciting. Also, we had some problem with the projector, so my laptop is sitting there right now, which is actually quite convenient for me. I did a talk last week where I didn't talk, it was a new one, and I haven't done it before. And it was only a 45-minute time slot, and I thought I really have to speed up, and in the end I ended up finishing in 30 minutes, or 29 actually. So today I'm going to talk much more about myself, because I love talking about myself, to just stretch things out. So yeah, I'm from Germany, obviously. I have my own little consulting company. What we do mostly is we run stuff for an ISV. My company is the daughter, if you will, of an ISV, a software vendor. We make software for large logistics service providers. And it has been my job for the last 7 or 8 years to run these in our data center as a software as a service or a cloud offering, if you will. So I do that, and then I take as much time as I can to actually go out to clients and consult with them on everything Oracle, because that's just what I like doing. One of the cool things is I'm an ACE director, which means that, and it's another big thank you to OTN or Oracle, who's actually sponsoring me to come here and talk to you guys. So they're picking up the tab for the flights in the hotel, which is awesome. So thanks to Oracle. And it also allowed me to travel Asia just the last couple of weeks with Tim. So into Singapore, Perth, Shanghai, Tokyo, and Beijing, and spoke to audiences there. And I absolutely love doing that. So that's that. Company doesn't really matter. So the agenda for this first talk, as I said, SQL plan management. I want to talk a little bit about the optimizer and a little bit of the history of the optimizer and why we want to have something like baselines and management. I'll introduce you to the basics of how it works. And then I want to talk about a process that we have designed around one of our client sites with baselines management, which is called our implementation. And then I have 2 use cases in the end, just to show you how you can be creative with baselines. So yeah, I'm rather young. I just turned 35 yesterday. I've only installed Oracle 8 once and ran 9i twice, but nothing serious until 10G. And I bet most of you guys have more experience than me with Oracle. Oh yeah, let him in. That would be nice. So one thing that I've only ever heard about, I've never actually worked with this, is the Rulebase Optimizer. To me, this is a matter of legends. I've never really worked with it. But for this talk, I actually went and did some research on the RBO. Well, first of all, it's not being updated since version 7. I don't even know if it's still in 11 or 12. I think it's still in 11. It's not in 12 anymore. It's definitely unsupported.
Deprecated ages ago, but you can still use the rule hint for certain things, but it's not a good idea.
Yeah. Well,
on 11, some of the internal stuff is still using it.
I think on 12 something. I still see the hint in SQL for 12.
They'll never remove that though. Too much search and replace is beyond all.
All right. So just an example. If you did a table, if you did a query like this, give me all the attendees in this room, or where the room was the table, where the gender equals male, then I can tell that a full table scan is actually probably the best way to do this, right? But if there was an index on the gender column, the Rulebase Optimizer would always use that index no matter what the selectivity is. So it would be a bad idea. And if you had a query like this, where gender equals male and country equals Germany, then this would have very good selectivity here in this audience, probably. Maybe there's a second German hiding here somewhere, but not very many. But still, if you have 2 indexes, the Rule-Based Optimizer would pick the first one. So the first one in your where clause, that would be the index that would get used. This one wouldn't get used. So this is something I learned about the Rule-Based Optimizer. Joins, again, there's certain rules how Oracle determines how to do joins in Rulebase Optimizer. Let's not go into the details here because I may just embarrass myself. But what I would imagine is in Rulebase Optimizer times, most of the work had to be done by the developers because the way you write your SQL would determine the way the SQL would be executed, right? Which means that the developer had to think about which index do I want to have used, which predicate has the biggest or the best selectivity, put this first in my where clause. They'd have to think about that. We DBAs would have a rather easy life, or would have had a rather easy life, because there isn't much that we can do at runtime. We'd have to change the SQL, and our plans would never change. They were very predictable. Not even bother with gathering stats and all this nasty stuff. Just throw a SQL at this thing, and it would just stay the same. And if anything went wrong, developers were usually to blame. That's good. So, but then Oracle 7 changed the game. They introduced what's now known as the CostBased Optimizer, which is the default optimizer, which is, even though I'm talking down on it, it's actually a very good piece of software. The way the CostBased Optimizer works is it uses statistics on the tables and the objects that you have. It'll then just construct all the possible execution plans that it can use to fulfill this query, and stick a cost with each plan. So each index access, each row access, each table scan has a certain cost associated with it. It'll construct all the different plans by different join methods, different access paths. We'll calculate the cost with it, and the one with the lowest cost is the one that the optimizer would think is the best plan. And the good thing is this adapts very well to new situations. So if your data changes, if you get more data, if you have less data, if your data is skewed, if the example I did before where one column had a very good selectivity, the other one didn't, these are all things that the cost-based optimizer can do very, very well. It also means that writing SQL is very easy because it doesn't take much to write SQL. You just write it and it'll just work because you don't have to think about which way you actually put your where clauses and in which order you join your tables together. Just write it out the way you think it works, and the optimizer will take care of that. So that's all very good. The problem for us DBAs is that there are still a million things that can go wrong. I mean, there's probably a billion things that the optimizer gets right, but there's also some things that it just doesn't get right. Execution plans can change, which is a good thing because, hey, they can change. They can adapt to something better, but they can also change to something worse. So usually when statistics aren't right or cardinality is weird, things may just be wrong, right? It just may not be working so well. And we call this problem the flipping plans problem. So whenever there's a cost at the threshold, if you will. So there's two plans, and the optimizer has to have a threshold between choosing one plan over the other, which is a very binary thing. Choose this plan over this plan. It's a very binary thing. But in terms of runtime or whatever the database has to do, it may not be so binary. And then the plan may just flip from this one plan to another one. And I've had no customer ever call me about, hey, I didn't do anything, you didn't do anything, but all of a sudden everything's running, or this query is running faster. But we had lots and lots of problems, especially with this one customer, about plans flipping and then suddenly not working as well as they used to anymore. And I'd get lots and lots of phone calls with this. This whole concept, I'm just trying to be smart here by quoting a Nobel Prize winner, it's called loss aversion, and this guy Daniel Kahneman studied this in human behavior. The game he liked to play was a coin flip game. He would ask audiences if they wanted to play a coin flip game. Say, heads, I win a pound, it's in this country, tails, you win a pound. And he found that not many people wanted to play this game with him, even though the odds were just 50-50. So he said, well, I'll give you 1 pound and 5, it's pennies, right? And 5 pennies if you win, and if I win, I just get a pound. And still people said, I'm not going to play this game with you, even though the expected winning rate was positive, right? So it took him about £1 and 10 pennies to actually convince people to play this game with him. And he studied this in other ways as well. So whenever you lose £5 or $5, you may find this worse than the positive emotion of finding $5. He calls this loss aversion, and he says that humans generally like to avoid bad situations, even if that means not getting the good outcome. Does that make any sense? Am I being smart? All right. So again, with this flipping plan problem, the fix is usually very easy. So if a customer calls and says, well, this SQL is running, or if a client calls, this SQL is running slow, the fix is usually easy. It's usually something that's wrong with statistics, something that we can fix by just clicking on Enterprise Manager to the SQL Tuning Advisor. It's usually very easy. You can also stop plans from flipping by just stopping or managing how you gather stats. You can just stop gathering stats or just gather stats in certain intervals, not every night. Maybe just once a month. You could gather them in a holding area, inspect them, and then just release them into production. I also see developers just put in tons and tons of hints to enforce the plan that they think is right, which basically takes us back to Rulebase Optimizer times. And I had customers tell me, please, can you enable this Rulebase Optimizer again? I remember from my childhood days that everything was much better and we didn't have any problems, so please do this. Which I basically translated to, please freeze our plans. Please make sure that our plans do not change for the worse. This is how I actually understood my client's requirements. And this is where SQL plan management and baselines are helpful. If you're looking for stability in your plans, baselines are what you want to look at. Because it helps with this flipping SQL plan problem. It prevents plans from flipping, either for the good or the worse. I found it works rather better for static apps. So if you have a static OLTP app where your code doesn't really change too much, it works really well. If you have a data warehouse, it may not work with the same benefits that I have. But most of my customers are OLTP, so that's cool. And again, if there's anything wrong with plans, it's usually easily fixed. But the consequences can be nasty in an OLTP system. It could mean that stuff is just not running as fast as people would expect it to, or yesterday's performance was probably fine. If you can get yesterday's performance guaranteed for tomorrow, that's what customers want. Problem is, if you get these flipping plans, it usually happens right after you get the statistics, which is usually in the middle of the night, which is usually the time where I do not want to get a call about a performance problem. So our goals for SQL management when we implemented this was we wanted to prevent random changes for the worse. We just wanted to freeze all our execution plans. And then introduce something like a change management process. And if you think about it, we have change management in place for most things. We wouldn't just replace hardware, we wouldn't just replace Oracle versions. There's a change management process involved when you deploy a new application. But these plans, they can just change whenever they want, right, by default. So we wanted to introduce a process, a change management process, where you actually want to find and evaluate these things, review, and also document all the plans that we approved. So one step back, what is SQL plan management? It's really just one more layer to the CBO. It doesn't change the way the CBO works. You don't have to unlearn or relearn anything new. It's really just another workaround around the CostBased Optimizer. Think of it as a quarantine area, an area where you collect new plans or new plans, but you don't actually execute them yet. So you put them in this quarantine area, store them there, and have the chance to evaluate them, to check if they are actually better or worse than the plan that you already have. And then it'll give you the decision to actually evolve it or not evolve it. A baseline is actually just two things. It's basically an outline, so they store all the hints that are needed to regenerate a certain plan, and they also store the hash of the plan. Everything that has to do with baselines is usually being accessed to this table, DBA SQL plan baselines. And that's what I just said. Oh yeah, cool. You can examine this the set of hints by giving the plus outline format clause to the DBMSX plan, display cursor thing. I'll have an example right in the next slide. These are all stored in something that's called the SQL plan M. I knew what it was earlier today. And it has the planish value. So yeah, well, we go to it. So this is really small, but it's just select display SQL plan baseline or display cursor, give it a SQL handle or a SQL ID if you just do SQL cursor, and then add format outline, and that will give you this information, which is even smaller. But this is just something I copied. These are all the hints that were used for this one query that I was looking at earlier today, that were used to reproduce this execution plan. And it says SQL management B, SMB. I knew what it was earlier today.
Baseline, isn't it? SQL management baseline.
No. whatever. Base? It could be base. Source the plan hash value. This is the plan it generates. If you run this thing, this will generate this thing basically twice. It'll give you this one thing from the SMB, and then it'll tell you the outlines it actually used to produce the plan, and they could be different. So if this is invalid, or if this doesn't help to recreate a plan today, it'll just come up with something it makes up on the fly, which is then displayed further down in the report, and that can be confusing. The point I want to make is just a baseline is really just this, the set of hints that are used to, or an outline with the hints that are used to recreate a certain plan, and the plan hash value. That's all you need to know for now. A SQL baseline can have a couple of statuses, and this can be a bit confusing. So there are three status, or three columns that can have different values. There's an enabled flag, an accepted one, and a fixed one. I've got no idea why enabled would be ever set to no, and it defaults to yes, and it doesn't really do much. Actually, I do one case where it makes sense to change this, but let's not go there. The really important one is the accepted flag. If accepted is set to yes or true, yes. The optimizer can actually, or the runtime manager can actually use this plan to execute it. If it is set to no, it's in the quarantine area. Then we have a baseline, we have it stored, but it's not cool to use it. And a baseline can also be fixed, and fixed would mean I really want this one to use this, and don't even bother collecting new ones if you find potentially better ones. So again, enabled is usually set to yes. Accepted is the big flag that you need to change, because this means if it's set to yes, we can use this to actually execute SQL. If it's set to no, that's our quarantine area where we just store SQL baselines but don't actually execute them. And then if you are really happy with a certain baseline, we can set it to fixed, which means use it and don't even gather new ones. Let's look at how parsing works and how this whole baseline issue fits in with the optimizer. So this is a very simplified thing. We have the SQL statement and we execute this because we have a plan. It's not as simple as that. The first step is a SQL ID is being generated. A SQL ID is being generated for every unique SQL, and the unique SQL is based on the hash of the SQL text. And if I have two statements like this, that where stuff is written in capital letters here and in lowercase letters here, these would actually result in two different SQL IDs, and they would follow two different paths for everything that follows. It also means that if you're using bind variables, you're not using bind variables, if you're using literals, like here, if you have 1, 2, 3, 4, 5 persisting values, it would also mean that each one of them would get a different and unique SQL ID. So if we have a SQL ID, the first thing that Oracle will do when you execute this is it will look in the shared pool to see if the SQL ID is already in there in the SQL area. If it is, that's cool, we'll just execute it. Unless there are a bunch of reasons, 60-something reasons, why we would not execute a SQL even though it's already in the share pool. Adaptive cursor share won't be one of them. Some more are there. There's a bunch of reasons why, but generally, if it is in the SQL pool, we just in the share pool, we just execute it. If it's not in the share pool, we actually have to hard parse, and this is where the optimizer does its work. This is when the optimizer gets all the different plans that are possible, calculates the cost, and comes up with something I call the winning plan. That's the plan with the lowest cost. So now we have a winning plan. The optimizer actually done all the hard work, had this winning plan and said, yes, I have this new plan that I think is really, really good for executing this query. And now if you have SQL management enabled, it will look up the plan that I just came up with, the winning plan, in the baseline table, in the baseline area. If it is already there and it has an accepted flag set to yes, the winning plan will be used. We'll just run it, we'd execute it, everything is fine. If there's no baseline at all for the SQL ID or for the SQL handle, we will, let's just say we'll edit and set to accepted equals true. Actually, I have to control this. If there is a baseline for this plan in there, but accepted is set to no, no, there's another one that's like, I'm screwing this up. if there's, let's just go back this one step. Let's just pretend this had never happened. So we have this new winning plan. If this plan is already in the baseline table and has accepted set to yes, we'll execute it. If it's not in there at all, we'll just add it now and execute it. If there is a baseline or a plan in there for the same SQL ID, but it's not the one that we came up with, we will add the one that we just found, the winning plan, give it a flag of accepted equals no, and execute the one that is accepted equals yes. That was much better. That make sense?
And more importantly, that was correct.
That's good, because it felt good. Okay, so that's really important too, because that's one of the main points that I want to make in this presentation, is that you get how this works, and you get how this part down here ties in with everything else the optimizer is doing. So that means if you actually want to work with baselines, you have to do a couple of things. First is you have to enable the use of baselines. Then you have to think about how to actually add baselines to my systems. There are two approaches. You could do it automatically or manually. And that just lets you add baselines to your baselines. Eventually you want to evolve baselines, and evolving means you have to do something to the baselines that have accepted equals no. And then you also have to think about janitor work, so deleting unused stuff and just cleaning things up. One of the prerequisites if you want to work with baselines is you have to use bind variables. If you don't use bind variables, then all your SQL will actually generate a new SQL ID, and it's a big pain to manage all of these with baselines, because it means you have, so my customer, for example, the one that we did this for, they still have like 5 SQL statements in their systems that do not use bind variables, and they have like 12 million customers, and it's the customer ID that they put literals in, which means that if you don't do anything, we'll have 12 million times 5, that's 60 million different, very unique SQL IDs. And that's just a pain to manage. So I have a job that just deletes them for now, and I have, filed tickets with the developers to please fix this and use bind variables in this place. But if your application has many of these, then good luck with SQL management. It's just not much fun. The other point I want to make is, if you do schema level virtualization, it really helps if all your objects and all your schemas have the same names, including indexes and stuff. The reason for this is SQL management works instance-wide. So if you do a select star from T, where whatever, and you execute this in different schemas, then the baseline that will be used will be the same. So if you gather a baseline in schema A, then schema B would use the same thing. And if schema A has an index on table T that has a different name in that schema than the index on table schema B, then it may just not work. You also have to be careful when you drop indexes, because that could lead to accepted plans that aren't valid anymore. So if one of your accepted baselines is calling for an index scan, and then you drop this index later, you still have the accepted baseline using that index, but it will always be invalid, right? I think these are a couple of the gotchas that you have to be a little bit careful about. So first thing, enable the use of baselines. There's this parameter, optimize use SQL plan baselines. The good thing is it's true by default. So by default, the optimizer would always look for each new winning plan after each hard pass. The optimizer by default will look in the baseline table and check if there is already another plan for the same SQL ID. That's on by default. If you don't use baselines, you can probably turn this off and maybe save a little bit of performance there. It's just on by default, which I find very convenient. Which means the big work is really just creating baselines, adding stuff to your baseline table. And there are 2 or 3 ways to do this. One is auto capture, which is the one that I really prefer and really enjoy doing. You could import stuff from a SQL tuning set, and that's the only option really that requires you to have the diagnostic and tuning license or diagnostic and tuning pack, because SQL tuning sets is something you only get with the diag or tuning tag. I don't know which one. But this whole baseline thing and SQL file management, that's included with Enterprise Edition, so no need for extra licenses. You can also import from the cursor cache, or you can import baselines and exchange them between systems. If you just wanted the auto capture, that feature is controlled by the optimizer capture SQL plan baselines parameter. This one is false by default. So by default, you will not gather new baselines. That's one of the reasons why I got stuck when I was explaining this thing, because by default, if there is no baseline, the optimizer or Oracle would not add this new plan to the baseline table, the new winning plan, right? That's one of the reasons why I got stuck in that diagram thing. Also, my advice would be, do not modify this on a system level. You could do this alter system and just do it for the whole instance. My advice would be not to do this, because you will gather a lot of junk. Everything that you type as a DBA will get recorded. Everything that Enterprise Manager agent will do, everything that Oracle is doing internally will have baselines, and that's probably something you don't want to manage, and it may even be better not to manage it. So my advice would be, do this only for your application users and put a logon trigger there. Put a logon trigger for your application users and capture or auto capture for them only. Auto capture only captures on the second or sometimes the third execution. So if you just enter a SQL statement once, it will not get recorded as a baseline table only on this. It will only do this on the second execution. If you have this parameter set and it's the first time you capture something, this will get auto-accepted. So the first time you execute, the second time you execute a statement, you will add this to the SQL baseline table. And if it's the first one, it'll have the accepted flag set to yes or true. And if there is already one, we'll still add this, but set accepted to no. I talked about this system level, the session level, just makes sense. This is a link to Tim's website down here. Tim, can you read this?
I wouldn't go there.
Yeah, don't go there. But go there if you want to learn about how to import stuff from a SQL tuning set or the cursor cache. Actually, cursor cache is right here. Just execute this procedure, load plans from cursor cache, and you can do this. You can filter by SQL ID. I think there are some other things they can filter on, but you can. But it's really useful to just do single SQL IDs or just import the whole cursor cache. Oh yeah. SQL, you can filter on SQL text. See, I forgot that. If you do manual import, it's really good if you just want to be very surgical about what you do. If you just want to fix executions for a certain problematic SQL statement, I think it's really good to just fetch one of them from the cursor cache. The system one, if you just do alter system, will capture tons of junk. And I already talked about this. Oh, but both methods, if you have a baseline in there and it's not set to fixed, you will get a new one. So if you just import one problematic SQL from the cursor cache by doing this, filtering the SQL ID, then any subsequent potential winning plan will still get recorded and still get recorded in the baseline table with the status equals to unaccepted. That's just even if you have the auto capture to false. So if you do this, then your baseline table will eventually fill up. So first of all, you have all the stuff that you just imported on the first import. You have those in there. And then every time the optimizer does a hard pass and comes up with a potentially better winning plan, it'll get stuck in the baseline. I keep saying table. It's not really a table. It's not really a single table. It gets stuck in there with the status equals to accepted status equals none. So you have to evaluate them. And evaluate is this process of trying them out and then modifying the accepted flag. There's a procedure for that. It'll actually run the statement against the real data with the bind values that it recorded when it first did this whole capture process. Finding the winning plan, record the bind values that I gave it at that time. It'll run it with this. This may be good or bad. The cool thing is it'll actually run this against your data. The one thing you have to think about is run this at a time where the data in your table is actually representative. So we had issues where a table would be just purged every day, and something would make sense on an empty table. But whenever we did the evaluate, the table was actually full because it was that time of the day where the table was full, and then it would always evaluate to not being very useful. That's the only thing I have to say with this. But the real cool thing is, other than the cost, which is base really just an estimate. Running a SQL against the real data or real data from multiple tables with real bind values will actually give you a much, much better understanding of if a plan is actually better or not, independent of the costs. Reports the execution time, the number of buffer fetches, and so on. And with this procedure, you can choose to just have it report on the outcome of the check, of the verify operation, or if the verify was successful, if the new baseline was indeed faster than the old one, you can tell it to just accept this and set the accept flag to true. 11G had this job. It's called the automatic SQL tuning maintenance job. That job is on by default. It runs every night, I think. It will actually run this procedure, will actually run the verified process for you, but it will not actually evolve this. It will give you a nice report which looks like this. And it'll tell you, hey, I found this cool thing. You can actually implement it done for the SQL profile here. But the profile really just enables the baseline. Tells you can do this and you can enhance your performance. But you still have to do it manually. And I think that's quite sensible. But I wanted to have a little bit more control over this. So I wrote a little tiny PL SQL script that would just fetch all the unaccepted baselines, run the evolve function once, then parse the output, look for is this one better or not. If it's not better, I will record this with the baseline table. There's a very nice column called description that you can fill with your own stuff. And if it is better, I will record yes, it is better, and it's better by this much. So I do not actually evolve. I just I don't set the accepted flag. I don't modify this. I just take note if the first run of this actually reported anything significant. Right to this description column, successful, failed, and sometimes there are just errors where a baseline is not reproducible. So that thing runs automatically every night, and it comes back with a list of, or just marks these columns. So then I can just look at all my SQL plan baselines and the description column and just sort by where description equals success, and I also note the factor in there, and just order them by the biggest benefit or the biggest gain. And I will then run a second script against this to create a report. This will create the evolve report, which has the times and the buffer fetches for before and after, or for old baseline versus potentially better one. And it'll also give me the execution plans for both the old baseline and the new one. And I use this for documentation, so I can just put this in the ticket system. It has all the information that we would ever need. That's my poorly written PL SQL. No need to make fun of that. But that's the output of it. So that's how one of these, that's really just the verbatim evolve report. This is what you get when you run this evolve procedure. It'll give you the SQL handle it's been running for. Some of the other options, as you can see, commit is set to no, and this commit option determines if we actually changed the accepted flag. And this is the main part of the report. This is where it compares the performance of the baseline plan with the test plan, the potentially better one. And in this case, it said the new one would be about 1,000 times better because it takes much less time, and I really can't read it from there. And also the buffer gets are much lower. So that's just the output of the report. That's my SQL, and these are the plans. So this is the enabled baseline, as accepted yes. And as you can see, this was a full table scan. And then this one was the one that I just tested. Again, it was enabled, but it has accepted set to no, and it's using an index scan. And what happened here was this was a new table that developers just introduced. So it was empty when they first created it, and the first couple of SQL statements that went against it obviously used the full table scan because it was an empty table, and that was just the fastest way to go. Over time, the table filled up, and an index scan became the better way to access the data. But the optimizer wasn't allowed to actually use the index scan until we actually looked at it and said, yes, this is a good idea. Use the index scan. We want to evolve this. You can use this, and you don't have to use the full table scan anymore. So the first thing we do is this report, this thing here, This is now being auto-generated in a job. So every night I look for jobs or for baselines that have a successful evolve job. I auto-generate a ticket or a ticket system for this that has the report, which means it's being documented. The process with our client says we need to request for approval because they were really, really anal about this. Please freeze our plans. I don't want any plans to change. After they had the first 5 or 10 of these, where we actually asked them to please sign off on approval for evolving, they got tired of this, and we can just do this if we want. But we'll just accept them. But the cool thing is we now have a ticket with it. We note the ticket number in the description column after we actually have evolved it. Which means we have documentation both in the baseline table, both in the database, and also in a ticket system of something we did. Which means another cool thing, we have now documented everything cool that we do for the database. So we turned this whole issue around. So when we started this process, our client was giving us calls every week, like 2 or 3 calls, where execution times were not as good as they were before, and we were the ones in charge of fixing it, but still we were being yelled at. We turned this around to we don't have any plans that change for the worse, but every time we change a plan for the better, like this one, which is running 1,000 times better, we now have actually documented proof that we did something good for the company. And it just changed the perception of how we are being seen at this client. This is just another nasty piece of PL SQL that I wrote. It takes a SQL handle and a description, which is the ticket number. And again, we'll run this, or we run alter, and we'll set the accepted to true somewhere. I cannot find it. Here, commit, I guess. 12c changed the game a little bit, and there's this cool blog post by, I think it's Neil Chandler, who calls this a dumb feature. So in 12c, there's a new task. Well, first of all, this nice function or procedure, evolve SQL and baseline, is now deprecated. They now want you to write jobs for everything. So there's no more, let me just run this evolve thing once. No, now you actually have to create a job that runs this once and then is done with it, or a task. And there's a task by default called sys auto spm evolve task. This one will just nightly evolve all your SQL plan baselines that have the status of accepted set to no. And if they find it to be better, they will automatically set accepted to yes. So they will take this control away from you again. And I had this discussion with Carlos Sierra, who used to work for Oracle and was very involved with this stuff. And he calls this cowboy DBA versus German DBA. So where me, the German DBA, wants to have full control of when and how I actually evolve my baselines. He says he encounters many cowboy DBAs back in the US where people just want things to change because then they come in and be the knight in shining armor to save the day. So that's a little bit about the beef that I have with the 12c auto job is it runs at night. It runs in the maintenance window when I do not want to get a call. I think it's great that they just test the plans. But why not let me choose the time when it's really right to evolve them? I would rather just come to the office in the morning, have my coffee, be settled, then do things like evolve all these nasty plans, and be ready for the call to get in, instead of being in bed and getting a call about bad performance or getting the call at 7 a.m. in the morning when I drive to the office. The one last thing you have to do is you have to do a little bit of cleanup. So with my process, and I think the same thing is true for the 12c auto evolve job, is you have to delete the ones that you have looked at, that you have tried to evolve, and that didn't really work out. You don't want to store these in the baseline table forever, because you want to give them a chance for re-evaluation. So with the process, the way that we set this up is, if we evolve this once and we find that the new plan is not faster than the old one, and by the way, not being faster means if it's not at least 10% faster than the old one, it will be considered a failure. So if it's just 8 or 9% faster than the old one, it's still faster, but it's still deemed a failure for the evolve process. So if you just leave them in there, I will not evolve them again. That's why I delete everything that I've looked at after a few days. And then if the optimizer comes up with this plan again and says, yay, this one is better, it will get recorded again, it will get evaluated again, and if it is actually better that time, we'll do something about it. This is just a review of the process. We capture all baselines for all SQL automatically for our application server users. This is really cool because we gain stability for existing plans. With this, we actually guarantee that plans do not change. The potentially better plans, the ones that the optimizer comes up with, are evaluated automatically. And these are a lot. So the optimizer thinks it's really, really smart, and it'll come up with hundreds of plans a day that it thinks that are better. But then we have this job that runs every morning and that actually runs the potentially better SQL baselines against real data. And we find that there are maybe 1 or 2 a week in our system that actually pass this evolve test. So that's not a lot of work. So 1 or 2 tickets a week just to look at these things, and then most of the time just deciding, yes, this is really a good idea. Not that much of work. Plus, we get to prove and document that we actually did something good for the company. And with this, and if there are no questions, I have 2 examples for cool things that we did with this. One example was this one. I just resorted these slides. Let me just check what I did here. Let me try to fix this. We had this one query that didn't run very well. It had a SQL ID, and this was using a hash join. And don't ask me how, but just by looking at it and being really, really smart, we were able to tell that a nested loop join would be much, much better here. But it was still using a hash join, and we wanted to know why was it using a hash join. The reason it was using a hash join was that this query was going against a view that had a hash join hint in it, which I didn't really like very much. But there was not really much I could do about it. I knew that if I was to remove this hint from the view, this SQL was going to run much better, but I didn't want to just modify DDL on my database because I thought maybe there's something else that really, really needs this. Maybe, just maybe someone actually thought about this and this is a good idea, which it probably wasn't. Anyway, so there was this hint in there, and the SQL that I had should not use this hash join hint. So this is where this whole reorder thing just freaks me out. Nested loop join was much better. Can't do this, didn't do this. So my solution was I just fired up a session, set the optimizer ignore hints parameter to true, executed a statement twice, and that meant the optimizer was now recording the baseline, no, the plan that it thought was better, right? So I set this, which means ignore the hash join hint in the view, executed it twice, the optimizer did a hard parsing, came up with a better plan, the one with the nested loop join, and added it to the baseline table as an unaccepted plan, but that was easily fixed. I just set that one to accepted, deleted the old one, and made sure that every subsequent execution of the SQL ID was ignoring the hint. Does that make sense? Cool. Other cool thing, and this is not me, this is Maria's blog, is it's a cool idea to, if you still have databases using the Rulebase Optimizer, if you have managers that still want to keep them on 9 or 10 for the RVO, here's a cool upgrade path. You export the plans that you have generated with the RVO, either from 9i or 10g, with outlines, or you import the database into a newer database and set this compatible parameter to 9. And you import this into 11G or 12C database, which means you import all the baselines, all the plans basically, that were generated by the Rulebase Optimizer. Make these your accepted default plans for your system, and it'll guarantee that even in an 11G or 12C database, your SQL will use the exact same plans that it would use if you had still be running the Rulebase Optimizer, and I just stopped making sense. The cool thing is, if you do this, you guarantee to your manager that you are still using the same execution path as the 9i database with the Rulebase Optimizer would. But you can enable the CostBased Optimizer. The CostBased Optimizer will do its magic. It'll collect better plans, and then you can look at them one by one and decide if you want to enable the new plans or just stick with the old ones. Instead of just doing an all or nothing approach where you just switch everything from RVO to CVO, which can be a lot of pain, I guess. You can slowly review except by one. A few things that are a bit annoying about using baselines is this baseline table has something called a SQL handle, and that's not the same thing as a SQL ID. You can join them via signature. There's a column called signature, and that joins to the exact matching signature in $SQL. And the same is true for plan name, which is what they use, and the plan name is not the same as plan hash value. And I know somebody told me why this is the case, but I forgot. So if you know and you want to try me again, tell me why this is the case, and I'll happily try to learn this. I know someone just told me I think it was just 10 days ago. So the next ideas that we have, and we still haven't done in this presentation, is 1.5 years old at least, is one of the ideas was we could export all the baselines from a production system, import them into test and staging, and make sure that test and staging use the same execution plans that we use in production, even though they may have different data, they may have different statistics. And then the idea after that would have been find the new SQL baselines in the development system. So when development is putting in new SQL, what we would do today is we would just bring them in production, and the first time we execute them, or the second time we execute them, we would just store the baseline for that and just auto-accept that. If you wanted to be even more careful, we could look at the new baselines in the development system, export them from development, import them into production, so we have a baseline in production even before we have the SQL in production. But that sounded like overkill to most people, and we never really got around to doing this. So I hope I got the point across that I really like SQL for management and baselines. If you don't want to use it for your complete database, for your whole database, the way we did, as in please freeze all our plans, we don't want to have any changes. If you don't want to do that, it's still a very, very good tool for surgical stuff. So if you've been using profiles or outlines before, this is the new profiles and outlines. This is what you do if you want to just fix the execution plan for 1 or 2 statements. There are a lot of interesting border cases, and these all are around what happens if the baseline plan that I have is not reproducible, because then weird things happen. And it's flexible enough to your needs. If you have any more questions, please ask away. How am I doing with the time? Still too fast, but I think that's good.
Can you just run through the difference between, see, it's great in 11, but you said they've thrown it all away by 12.
Oh no, so the stuff is still in there in 12, it's just the management has changed.
Right.
So in 12 they changed the, so this procedure that they have now, the one that's called Evolve SQL Plan Baseline,
Yeah.
it's still there, you can still use it.
Right, good.
One annoying thing is the report format has changed a bit, and I have to change. So
Past that.
yeah, because it's really annoying. It just returns a large amount of text, and I just parse it. And so the format of that has changed, so I'll have to fix my parser, which is not the biggest deal. They want you to use this task thing, where you set up a task for everything, which I find annoying if it's just about evolving the single baseline. I don't want to. I mean, I just want to do this, right? I don't want to set up a task to do this because I don't want to do this every day. That's the one change. There have been tons of issues around. There have been performance problems with it. There have been issues in 11.201. There have issues where it didn't use an accepted plan, but it told you it was using one. There have been issues. Most of these issues are fixed. So I'm really happy with the way it works in 12. I'm just not happy with the way they implement the management. And the other thing I wanted to mention was how with 12 they just snuck in this thing. They call it adaptive something. I think they call it adaptive baselines now, or adaptive SPM or something, because everything is adaptive now in 12c. Where they just decide, oh, we just do the evolve and processing for you. And I think that's something that you should just be aware of. In all the 2 years that we've been doing this now, there hasn't been a single case where a baseline that evolved positively shouldn't be evolved. So I think the concept of a job running at night and just evolving everything automatically is probably fine for most of us. But that's one of the things that I changed from 11 to 12. And I liked how in 11 it was still it was there, it was telling you that things changed, and in 12 it's more of a, if you enable this and if you just capture stuff, we will automatically evolve it for you at night. And I think that's good for most people, but you should be aware of what it's doing.
Is the automatic evolve job on by default?
Yeah.
Scheduled?
Yeah. It's on in both in 11 and 12, but in 11 it just gives out recommendations, and it also gives out recommendations about hey, you should create an index, you should create materials view, all the good stuff. But you still have to click on it and tell it to accept it. And the automatic evolve job in 12c will evolve, verify it, and if it finds it to be better, it will automatically set accepted to yes.
I used to work with Neil Chandler actually, but it makes absolutely no sense. I can see what he's getting at, because all it's doing is reverting to what used to happen with plan flip-flopping, except it happens in a scheduled job.
Well, yes and no. Well, the good thing is it actually evolves it, right? It actually validates the new plan against real data.
Yeah.
So the cost may be off, because cost is really just an estimate, and cost has so many factors where it can be wrong. Mm-hmm. Once you actually execute a new plan and compare the actual runtime of two plans, you are very, very close to if it really is a better plan or not.
But isn't that the same kind of 95% thing you used to get if you didn't?
Oh, it's much better. It's much better. It's much better.
Surely it's just going to evolve the plan that it thinks is the lowest cost, and then promote that plan, whether
it's
is
not just
really
cost though, because it actually runs a statement, so you get
I see.
cost can be misleading.
Oh yeah.
Yeah,
Yes.
okay.
So the baseline evolve process actually runs the statement,
okay.
and then compares the runtime, not just the cost. Because otherwise, right, it would be really useless. The other thing that the job does not do for you is disable or delete the old baseline. So the 12c job will auto-accept baselines that it finds to be executing faster than the old one, but you may still have both baselines in there. And that's perfectly fine. You can have multiple accepted baselines for a single SQL statement, which could be even desired if you have things like adaptive cursor sharing, for example, where depending on your input values, you want to have different execution plans. But it could also be annoying. So the case that I showed you, where I was switching from a full scan to an index scan, I would probably want to delete the full scan, because it's something I would probably not ever want to have again. And again, that's one thing that the job is not flexible enough to do. The automatic job will just set accepted to yes for the new one. It won't do anything about the old one, and then you have to clean it up manually.
The other point on the deletion is, if you delete, presumably the next time that statement executes, it's just going to say, I've got a better plan.
Yeah, so if you delete it, and then the optimizer gets around to hard parsing again, and finds that it comes up with the same plan again, because it thinks it's cheaper, it'll get stuck in the baseline area, table, whatever, with accepted set to no.
Yeah.
And then you'll go through the whole evolve process again. And then if evolve finds this plan to actually be useful, be faster than the current baseline, it'll be in there again.
Yeah, so presumably every time you shut down and start up again, you...
Oh no, this is actually being persisted. The SQL plan baseline stuff, that's being persisted through reboots.
But will it not just say, I haven't... It won't look at that, it'll say, I'm going to hard parse again, or will it'll look in the plan table and say, I've already got a plan?
Well, the optimizer will always still hard parse whenever it thinks it needs to hard parse. But after hard parsing...
If the statement isn't in the cache is what I'm getting at.
If it's not in the cache, it'll be hard parsed. Then after the hard parse, it comes up with an accepted baseline, it'll execute this. If it comes up with a SQL ID that has another accepted baseline, and this one is not accepted, we will not execute this. We will record this, but we will execute the one that is accepted in the baseline. So yes, after each reboot, we may come up, because we're doing a lot of hard parsing after that, chances are that we will come up with more potentially better plans, but we're not going to execute them until we actually have made sure that they are good.
Okay. Get that.
All right.
Container database, is the scope within one plugin or the whole database?
I don't use container databases.
Isn't everything got a con ID now? I think it's actually down to individual pluggable databases, if I remember rightly. But don't quote me on that, I'm probably wrong. But I'm pretty sure all of this stuff now has got a con ID against it, so all of your SQL plans are container specific. Because you could have the same objects, have the same names, with very different profiles of data, So the SQL plan being shared would be a complete disaster.
Well, it can.
Have a look at $3 SQL and stuff like that, you know, and I'm pretty sure if I could be bothered to look it up on my phone, read the fucking manual. I'm pretty sure it's got con ID.
Yeah, I would think so too. But it could still be a big disaster even with schema virtualization. But it would make sense to store it in the per pluggable database.
And if it isn't, it probably will.
All right. Any more questions?